Dear students, this is Dr. N. Venkatachalapathi, Institute of Aeronautical Engineering. I am going to discuss on some of the problems related to metal casting, especially the solidification time. Okay, how do you solve the problems in a solidification time? So, dear students, most probably these type of problems are very simple and important. Only a few concepts are required for the solving the solidification time. In general, so there will be a metal casting. They have to prepare the pattern and pattern design and the preparation of the mold cavity by using what you called mold cavity with the hand molding or machine molding. Then molten metal can be prepared with the some furnaces like cupolo, electrical and induction furnaces. Once you have to extract it from the molten metal, you can pour the molten metal into the mold cavity. So then by giving some solidification time, this is what if you give the solidification time, then obviously how much you can able to extract that cooling time, and which gives the good mechanical properties and improve the quality of the casting. Okay, so look at this type of case study and how do you explain. Okay, so in general the main principle involved in this solidification time is, so the term solidification time can be defined as the total solidification time TTS, which is gives rise to time required for casting to solidify after pouring. This is very important. So for example, you can see there will be drag box and cope box. This is the component, and there will be a riser and the screw basin, and how you can pour the molten metal. Okay, so this is screw, riser and in gate. Okay, three screw, riser, in gate. Okay, so here obviously what will happen, so the total solidification time TTS, which is gives rise to time required for casting to solidify after pouring. So whenever by pour the molten metal, immediately due to that heating in red hot stage, more than 1400 degrees centigrade temperature of the metal is there, then obviously you should give some solidification time. So that solidification time, how much you can able to give, that you should determine the designing of these castings also. And that is why you need to uh, focus on the how much time is required to have the solidifying of that casting process. Okay, and TTS is depends upon mainly size and shape of the casting. Another interesting thing, whatever the size of the casting and shape, it is simple shape or some complex shapes, and what are the size, it is a small, medium and large size of the casting is required. The totally this depends upon the some Corinov's rule. A scientist called Corinov's person, he has derived the expression for the how do you determine the total solidification time. TTS is equal to some molding constant into volume divided by surface area whole power n, where n is the exponential with a typical value almost all, that n is nothing but 2, v is the volume of the casting, A is the surface area of the casting. Okay, and obviously N can be exponent with the typical value almost all they prefer 2 only, and whereas Cm is the molding constant, especially in any type of this type of problems, they may give the solidification time, volume and surface area. You have to determine depending upon the setup, either it is a cylinder, how do you determine the volume and surface area, if it is a cube, and how do you determine the volume surface area. So like that, even if they will give the solidification time, volume and surface area, and you need to calculate easily the mold constant. That Cm is the mold constant, which Cm can be defined as total solidification time divided by V by A whole power n. So this method also can be determined this molding constant effectively. So now let us discuss another problem which is also very very important for this metal casting process. So this problem can easily understand. The students also can focus how do you solve these type of problems. So this type of problem they may ask in the especially gate examination, some competitive examinations, IAS, etc. Okay. So first look at what is the problem. Data is given. Total solidification times. Total solidification times for three geometries. So three geometries are to be compared. For example, first one is circle, cylinder, cube. This is also called the sphere. This is a cylinder. This is a cube. So three different geometries are to be compared. And first one is sphere. They have given the diameter of the sphere is some 10 centimeter, and the cylinder diameter of the both is 10 centimeter, and last cube with each side is 10 centimeter. Side L is equal to 10 centimeter. Okay. So now the same casting alloy is the same casting alloy. What will happen? The solidification conditions are used in all the three cases. Solidification alloy can be used in all these three cases. Then which casting would solidify faster? It is very interesting. So if you take the three different type of geometry, one is sphere and a cylinder and a cube, only thing is different dimensions. The diameter for the sphere is 10 centimeter, cylinder is 10, and cube is 10 only. So what I wanted to express here, in this case, which casting would solidify faster? Either sphere or cylinder or cube. Which type of casting would be solidify faster? So majority people are telling that by calculating the solidification time in the three different cases. For example, first case you can see sphere, the volume already given. So otherwise you need to calculate the volume of the sphere, and similarly volume of the cylinder, okay, and volume of the cube. So then parallelly surface area of the sphere 1, how we can determine surface area of the cylinder 2, that is 471 is the surface area. Cube is surface area is 600. Okay. So the data is given, volume is given, surface area is given, but only formula for the Cournot's rule is total solidification time. Total solidification time which is equal to, okay, solidification time which is equal to some constant factor volume by surface area whole square. V by SA, surface area whole square. So where B is the constant parameter. So and the data is given, sphere volume is given, surface area is given. Cylinder volume is given and surface area is given. Cube also volume is 1000 centimeter cube and surface area 600 centimeter cube. Now let us see how to solve this problem, this simple problem, for easy understanding the student, so that they can attempt any competitive examination like GATE, IAS, etc. Okay. So we don't have the mold constant B. Suppose if you don't have the mold constant B, but we were told that alloy used and conditions are the same for the three parts. Accordingly, B is same for the all the three cases. B is nothing but Solidification time for the sphere. First case, this is case 1. Solidification time for sphere V into, you can see the V by surface area. For sphere V 524 by 314. 524 by 314 whole square. Obviously, you need to have a focus on the sphere. Okay. Similarly, solidification time for the cylinder, same B into what you call that 785 is the volume and 471 is the surface area. Okay. Volume by surface area, so that you may easily identify that solidification time 2.78. And the third, last but not least, the solidification time for the cube also, which can be calculated using the formula Ts cube is equal to B into 1000 by 600 whole square. Okay. So surprisingly, that solidification time is essentially same for all each part. Same for all each part. We were asked which causing would solidify faster. Okay, would solidify faster, and obviously you can see all the three, sphere, cylinder, cube, all will get the same values. 2.78 B, 2.78 B, 2.78 B. So that surprisingly, solidification time is actually same for each part. We were asked which casting would be specified faster. So answer is none. Why? Because as all the three castings have the same value of Ts, obviously this can be asked for would solidify to do the better. Okay. So this is what about the problem we have discussed. All are same only. There is no changes, and at the same time, all the three castings have to be same value for it. Okay. So these are the some of the references which I have referred for this type of some advanced problems, and another Grover M also is available depending upon the modern manufacturing system. 5th edition, John Willie States. Okay, so thank you for this case study, and especially it is very useful for to understand this problem effectively. Okay, so good luck, students. Next session we'll discuss one more problem for this metal casting purpose. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.